Welcome back from the ad break, and let's continue with our lesson. So now we are going to be going into that second concept of our concept map, and that is like terms and unlike terms. So let's go into that concept. So we are first going to look at the like terms. So what exactly are like terms? Now, like terms are terms that have the same variables as the base and the same exponents to that base. So we need to make sure that they have the same variable and they have the same exponent to that base. Let's look at an example. So for an example here, we have 2a and 5a. Now these are like terms. Why are they like terms? Because they have the same base, which is the a. So they have the same, variable as a base, which is the a and the a. And if we look at the exponents to that base, then we can see that the exponent there to that base a is a 1, and the exponent again in the second term to that base a is also a 1. So those two are like terms. Now let's look at the following terms and identify why they are like terms. Remember, what are we looking for? We are looking for the same variables. We are looking for the same variables as a base, and we are looking for the same exponents to that base. So we are going to look at these terms. So the first pair of terms that we have there is 3x squared and 7x squared. Now, do they have the same variable as a base? Yes, they do, because the variable here is an x and the variable here in the second term is an x as well. Now, do those variables have the same exponent? Yes, they do. It is an exponent 2 and an exponent 2. What about 10ab and negative 4ba? Are they like terms? Well, yes, they are like terms. Why? Because do they have the same variables as a base? Yes, they do, because the 10 has a and b as a variable, and the negative 4 has a and a b as a variable. So even if the variables have been written the other way around, remember, multiplication is commutative. So a times b is the same as b times a. Now, do they have the same exponent to those variables? Of course they do, because we can see that the a has an exponent 1 in both terms, and the b also has an exponent 1 in both terms. Let's look at 5y squared x and 14xy squared. Now, first question, do they have the same variables? Yes, they do. We have an x and an x on both sides, or on both terms, and we also have a y and a y on both terms. But having the same variables is not enough. We have to make sure that those variables have the same exponents. So now let's look at the y. The y in the first term has a squared as an exponent, or a 2 as an exponent, and again the y in the second term has a 2 as an exponent. And what about the x? Yes, the x has a 1 as an exponent, and the x on the second term has a 1 as an exponent. Let's look at the last one there. It says 31p exponent 4 and p exponent 4. Now, are these two terms like terms? Yes, they are like terms. Why are they like terms? Because they have the same variable, which is a p, and that variable has the same exponent there, which is the exponent of 4. Let's now move on to our unlike terms. So we have already looked at those like terms, and we know that the like terms must have the same variable as a base, and they must be the same exponent to that base. So now we are going to be looking at the unlike terms. So what exactly are unlike terms? Well, unlike terms are expressions that do not have the same variables or the same exponents to those variables. So again, we are looking for the same variables and the same exponents, and if they do not have the same variables or the same exponents to those variables, then they are not like terms, meaning they are unlike terms. So let's look at an example here. We have 2a cubed and 5b. Well, firstly, we can see that these two are unlike terms. Why? Because they do not have the same variable. Of course, they also do not have the same exponent. So these are unlike terms. So even if the variables are the same, that is not enough to make them like terms. Remember, the variable must be the same and the exponent. So even if the variables are the same, if the exponents to the variables are not the same, these will be unlike terms. For example, we would have there a 9a squared and a 7a squared. They are still unlike terms. Yes, they have a as the variable, but they are unlike terms because the exponent is not the same. Let's look at the following terms and let's identify why they are unlike terms. Now we have 3x squared and 7y squared. They both have squared, but they do not have the same variable. Then we have negative 2ab and a 6b exponent 4 and an a. They have the same variables a and b, but the exponents to those variables are not the same. So yes, the a's have the same exponent 1, but the b's do not have the same exponent. Here we have an exponent 1, and in the second term there we have an exponent 4. So they are unlike terms. Then we have 5y squared x and 14x squared y. So of course here the same variable, but in the first term the squared is for the y, but in the second term the squared is for the x. So those are not like terms. Let's now look at the following expressions and we are going to identify the like terms. Now remember, we know what like terms are. We are looking for the same variable and the same exponent. So which ones are the like terms here? Now we can see that a 6pq is the same, or it has the same variables and exponents to the variables as the negative 5pq. So definitely those are like terms. And again, we can see that the 3a squared is a like term with the 5a squared. And why is that so? That is because they have same variable and the same exponent to that variable. What about this next one here? Well, the like terms, can you identify them? Yes, we have the 11x and the negative 17x. And those are the only like terms in that expression. Then we have the 3y exponent 4 plus 5 minus 30xb minus 25y exponent 4 plus 12xb minus 14. Which ones here are the like terms? Well, yes, we have the 3y exponent 4 and the negative 25y exponent 4. Then we also have the negative xb with the negative 30xb with the positive 12xb. What about that 5 and that negative 14? Yes, they will also be like terms. And why are they like terms? Because they are both constants. So yes, they are also like terms. And this last example there, we have there, that expression. Do we know or can we see which ones are the like terms? Yes, we have the 30p exponent 5 and the 4p exponent 5. What about that 63r exponent 5? It might have the same exponent, but the variables are not the same, so it is not a like term with these other two terms. Then we have a negative 16pr. Yes, it is a like term to that negative 7rp. PR and RP, they are the same because remember, multiplication is a commutative. Let's quickly go through our last concept on our concept map, and that is the polynomials, where we are going to be looking at what type of polynomials do we have. So what is a polynomial? Well, a polynomial is an expression of two or more algebraic terms. An expression that has 2 or more algebraic terms. Let's look at the first polynomial there, and that is a monomial. A monomial is an expression with one term only. For example, 2x cubed. Let's see examples of monomials. 6x exponent 4 is a monomial. 12q is a monomial. 42k cubed is a monomial. And ABC is also a monomial because it is one term only. What about a binomial? Now, a binomial is an expression which is a sum or difference of 2 terms. Now, take note, remember the addition and the subtraction sign is the one that separates our terms. So let's look at an example of a binomial. We have 2x cubed plus 20. The 2x cubed is one term and the 20 is another term. Let's see more examples of binomials. We have 6 plus 3x exponent 4. Those are 2 terms. We have 1 minus 5q. Those, of course, are 2 terms. We have 4x minus 2k cubed. We have those 2 terms there. And we have a squared plus 6a, and those of course are 2 terms there. What about a trinomial? Now, a trinomial is an expression which is a sum or difference of 3 terms. So we've already looked at one term, which is a monomial, 2 terms, which is a binomial. Let's look what a trinomial would look like, which will have 3 terms. So an example of this would be a 2x squared, that's one term, plus a 5x, that's another term, minus a 2, that is the 3rd term. So that is an example of a trinomial. Let's look at more trinomials there. We have 6x cubed plus 3x exponent 4 plus 1. Those are 3 terms. Then we have 1 plus 7q squared minus 5q. Those are 3 terms. It's a trinomial. 4k minus 3 minus 2k cubed, that is a trinomial. And lastly, a squared plus 6a plus 5, those are 3 terms. That is a trinomial. So that is what polynomials are. We have monomials, binomials, and trinomials. Thank you for joining us for this wonderful lesson. We hope to see you next time. Goodbye.